So ladies and gentlemen, this is the first time I've ever recorded a video while I had students around me. It's kind of weird. Okay, so we're going to learn the basics of circles today. And the first things first, a circle is a set of points that are all the same distance from some center. So for instance, this circle right here, the center is O. We would actually write that using a circumpunct. We do like this weird symbol and then an O. That means a circle with a center of O. Here we have this circle, or circle O we would call it, and we're going to start to look at all of the ingredients that make up this circle. You're going to learn some vocab. There's some vocab you're already going to know, but we'll go over it again anyways just to make sure that we're all on the same playing field. Okay, so a radius starts at a center and goes to the edge of a circle. So here's a couple examples. OB, that's a radius. Similarly, DO is a radius. So again, you have to start from the center and go to the edge of the circle, just like OB does and DO does, or OD or BO, whatever you want to call it. Those are all radii. And all radii are congruent in a circle because, go back to the definition of what is a circle. A circle is all points that are the same distance from a center. So you take that length of the radius, and no matter what way you go out, you start at the center and you go out that length, every single point on the outside is a radius length away from the center. That's how you make a circle. You get infinitely many points that are the same distance from that center. Okay, the diameter on this one, we have BD as the diameter. What makes it the diameter? Well, it's a line segment that starts and ends on the edges of a circle, but it goes through the center. So that's crucial that it must go through the center. So that's only for a diameter. So here's something that's interesting that you may have never heard before. Here's a chord. GF is a chord. And you might say, okay, what is that? A chord is a line segment on a circle, starting and ending on the circle. But what's interesting is it doesn't have to go through the center. It just has to be any line segment that starts and ends on the edge of a circle. So GF is a chord. CH is also a chord. And last but not least, this is kind of interesting, BD is a chord as well. You might say, well, what's the definition of a chord again? Remember, it starts and ends on the edges of a circle. So BD is a chord as well. It's a special chord that actually is the diameter because it goes through the center. But the diameter is still just a chord. FG is a chord, but it is not a diameter because it doesn't go through the center. Okay, now to some stuff that you've heard about but you might not feel that comfortable with. The circumference of a circle. That's known, that's the fancy name for the perimeter of the circle. And what we mean by that is circumference is the distance around the outside of a circle. The formula for circumference is 2 pi r. And now if you think about that, you see there's a pi in there. We'll talk about the number pi a little bit. There's also a pi is being multiplied by 2 and by the radius. A little interesting thing here is twice the radius is also known as the diameter. So circumference can also be thought of as pi times d, or pi times the diameter. So either way, you can say double the radius, multiply it by pi, or just get the diameter and multiply it by pi. That's going to be the circumference, or the perimeter, or the distance around the outside of the circle. Okay, so now we're going to talk about arcs. So an arc it's really a portion of the circumference. If you think about it, arc, it sounds like it's a curved thing. Well, that's what it is. It's going to be a curved length that's the outside of the circle. So, for instance, here's how I could say, let's say I drew something like that. I wrote HD, and then I drew this curved symbol over the top of it standing for an arc. That's how we mark an arc. So arcs, again, are some length or portion of the outside of a circle. So one thing that's interesting is, let's actually kind of look at that arc HD a little bit more. I could tell you that I wanted to look at the minor arc HD, and by minor, you should really think of, it's not that big of a deal. It's not going to be that big of an arc. HD, if I say the minor arc HD, I mean the smallest arc that goes from H to D. Now, similarly, I could say the major arc of HD, and if I say the major arc, I mean go the long way, or go the further amount of distance. So instead of here, the minor arc HD, if I said the major arc, that would mean take a trip around the circumference to go from H all the way to D. So the major arc is understood to be the larger arc, and the minor arc is the smaller arc. If you had a circle perfectly divided, the minor arc and the major arc would be the same. So that would be like a circle with a diameter. So for instance, if I said minor arc BD or major arc BD, since you're traversing the same amount of the circle, those would be the same. But so you might think this is a little awkward to talk about minor arcs and major arcs. Let's say I wanted you to consider this arc. Let's say arc had. That's another way for me to say the major arc, HD, because I'm saying go from H to A to D. So that's another way to kind of clear things up. So if you toss another point in there, it would be more clear how you're navigating around the circle. And then the last formula we have down here, for the area of a circle, area is going to be equal to pi r squared. So in general, I recommend interacting with finding the radius, because then you can get the circumference or the area quite easily. For circumference, you could just find the diameter, but it is nicer to have the radius, because then you could just jump right in and find the area. And for the rest of this video, we're going to go through things like area and circumference. Alright, so area examples. As a reminder again, area equals to pi r squared. So you take your radius, you square it, and then you just multiply it by pi. Don't use your calculator, don't deal with 3.14. Just give me the exact answer with pi in it, because that, once you get the decimals, you're really just approximating. So here we have this circle O, and let's say the radius is the square root of 7. So let's say we were given something like DO equals root 7, and let's give it some units, let's say centimeters. Okay, so then if we were to find the area of circle O, we have clearly identified our radius. Just like I recommend when you guys are doing area, you find your base, you find your height, you make sure they're perpendicular, put a B and an H on your paper. I'm going to put an R here because I have, in fact, identified that I have my radius. Okay, so the area of circle O, that's that circumpunct, that's a circle with a dot through it. Okay, let's see if I can make this circle with a dot through it a little better. So that's circle O. So the area of circle O, I've clearly identified things. Notice how I have an equation here, not just some expression that's like floating. Make sure you have an equal sign. Area of circle O, that's going to be pi, take the radius, and square it. Okay? So the area of circle O is going to be pi. Now, you guys should know that the square and the square root cancel each other out because they're inverses. But if you want, you could also say, if you don't feel comfortable with that, you have root 7. Squared means you're multiplying it by itself. Root 7 times root 7 is root 49. The square root of 49 is 7. So the area is 7 pi. And you might say, oh, look, I'm done. Look, I showed all my work. You did a great job. You, meaning me. However, don't forget your units. The units should be squared, because you had units of centimeters multiplied by units of centimeters. That would yield centimeters squared. So also you could do something interesting like, I don't know if I'm going to be stepping on anyone's toes by doing this, but let's do a couple of quick examples of other stuff. So let's say, let's keep messing with our circle, but let's say, I'm just going to do one example here, but let's just say that I had the circle above, I had a radius of root 7, so there's my circle O again, drawn down here, but let's just say I only wanted to find a portion of the area. Let's say I wanted to know, and I'm going to say that that little arc, let's say that little arc is 120 degrees, and I want to know about the area of this shaded region, okay, of this this wedge of pizza. I don't know about you guys, but I'm pretty hungry right now. Okay, so please make sure that the shadedness looks a little better on your paper. I'm trying to say the area of this entire shaded region right here. Okay, well, we know the area of the entire circle, so the area of this piece, and you might see this in later videos too, a piece or a portion of the area is known as a sector, just like a piece or a portion of the circumference is known as an arc. So if I wanted to know the area of this sector, well, I know the area of the entire circle is 7 pi. Well then, we know the area of the entire thing, again, is 7 pi. We have 120 degrees out of a possible 360. So it's like a portion. If you had 120 degrees out of 360 degrees, many of you guys, you're very savvy with math, you could say, okay, divide the numerator and denominator by 10. If you had 12 out of 36, that's the same thing as 1/3. So 1/3 of the entire area would be the area of this portion or this sector. So then we could write this answer quite nicely as 7 pi. Multiplying by 1/3 is like dividing by 3. So 7 pi over 3 centimeters squared. Okay, so that's a portion of the area. It's 1/3 of the area because you only swept out 120 out of a possible 360 degrees, so you only have 1/3 of the entire area. So that should make good sense. So that was different. I've never had a phone ring while I was recording a video before. Okay, so circumference, we remember that that's the perimeter, or the distance on the outside of the circle. Circumference is equal to 2 pi r. So again, let's make sure, let's say that this guy has, let's say that the diameter, let's say that that's rs. Let's say that we're given rs is, I don't know, 8√7 feet. Terrific. Okay, so notice, we're going to be annoying and we're going to give you the denominator, the diameter. So there's really two ways that you can interact with this. If I had asked you to find the area of circle O in this example, you would have to find the radius, and then you'd have to take half of that, and half of 8√7 is 4√7. But since I'm asking for the circumference, we could again remind ourselves that that's pi d, and we will take pi and we'll multiply it by our 8√7. And so what's the circumference? It's 8√7 pi, whatever the heck that is. And you could probably approximate it. Notice the units are in feet, because perimeter, we're just measuring one dimension of distance if we were to walk around the outside here. Also, if you wanted to find the radius, you could use just the 2 pi r. You could say 2 pi, the radius, that's going to be half of 8√7. We said that would be 4√7. We'll toss a 4√7 in here. This looks like a mess. Just clean it up as best as you can. If you had double 4√7, you have 8√7, and don't forget to multiply it by pi. That's how many feet the distance around this outside portion is. So also, just to kind of go a little above and beyond, you may see this in further videos, but I'm a firm believer that the sooner you see something, the more it makes sense. Let's say we wanted to find the length of an arc. So remember, arcs you should be associating with circumference, because circumference is the distance outside, arc is a portion of the outside. So let's just say that we wanted to find the length. Let's make another point on here. Let's say I gave you this point here, t. And let's say I wanted to know the length of minor arc st. Well, I'm going to give you a little bit more information. Assume that this was given to you. So we want to know this length, minor arc meaning the small distance from S to T, not if we went the whole way around. Let's say I'm going to give you another little hint here. I'm going to let you know that I'm going to give you that the measure of angle SOT equals 40 degrees. You're going to learn about this more in another video, but I want to show you now. if this arc is 40 degrees, it should make sense that since this is coming from the center, like if you actually drew this out, that arc is 40 degrees, it should make sense that this arc is also 40 degrees. So we could say the measure of ST is 40 degrees as well. That should fundamentally make sense. You're cutting out the same portion of a circle. So now if we wanted to know the length of ST, and remember this is an arc, so we're going to use the thing that deals with the length of the outside, meaning the perimeter, or the distance of the outside of a circle, namely circumference. Well, what we can do is, we knew that OS from above was equal to 4 root 7. That's the radius. Okay, this distance right here is 4 root 7 because the entire distance, otherwise known as the diameter, is 8 root 7. Well, we've already found the entire circumference to be 8 root 7 pi feet. Well now, and this example, the numbers are kind of ugly, but conceptually this still should make good sense. Well, this arc is 40 degrees. It's 40 out of a possible 360. So the length of ST, that's the arc symbol, it should be not just 8 root 7 pi, that would be the length if we went all the way around, but we should only be sweeping out a possible 40 of the 360 degrees that are in a circle. Now you might say, Mr. Morbido, that looks horrible. Well, 40 out of 360, that can be reduced to 1/9. Isn't it nice when the numbers are like that? So now we can even clean this up a little bit more. We could say 8 root 7 pi over 9 feet. That is the exact distance of just this portion. And you might say, well, hey, the numbers are ugly and it's kind of throwing me off. Well, what's the important thing? To know that you can use circumference to find the length of an arc. If you have 40 degrees, a central angle that's 40 degrees, that arc is going to be 40 degrees. That's going to be a fraction of 360. That's going to be 1/9 of 360. So it's going to be 1/9 of an entire circle. So we're going to take 1/9 of whatever the circumference is, whether it's some ugly number or, you know, you might have a nice circumference like something like 25 pi or something like that, and then it would be a little bit easier. So the most important thing is that we're just taking a fraction of the circumference. What fraction? Well, 40 out of 360 is 1/9, so it simplified quite nicely. And let's say I asked you to estimate this, because this might be kind of interesting. About how many feet is this distance if the radius is 4 root 7 feet? Well, root 7, we know it's near root 9, and root 9 is 3. So it's somewhere close to 3. It's somewhere between 2 and 3. I would say 7 is closer to 9 than it is to 4. So I'm going to guess the root 7 something like 2.6. So if you think about it, pi is a little bit bigger than 3. We have 3 times 2.6. Do this scratch work with me. We have 8. We said root 7 is about 2.6-ish. Pi is a little bit bigger than 3 over 9. I want to estimate this. Well, 3 over 9, that's like 1 over 3. Okay, so now if I had to multiply 8 times 2.6, that's going to be like 20-ish. So 20 over 3. This number, as ugly as it is about approximately 7 feet big. And all I did was I kind of converted pi to a little bit like 3-ish, root 7 to 2.6, and kind of reduced as best I could. So that kind of gives you a sense of how big this number is if you had to estimate or put a decimal to it. Again, the biggest idea is just understanding that you can find the entire circumference of something, and then you could actually figure out the length of an arc, because circumference is the length around the entire outside. The length of an arc would just be a portion or a fraction of that entire circle. All right, cool. So now here's your practice. I'm going to tell you that MN, you're given circle O, meaning O is the center, and I'm telling you that MN is 10 feet big. Your first two tasks are to find the area of the entire circle O, and then also the circumference of circle O. from there, I'm going to tell you that this angle is 36 degrees. Now, what I would like you to do, and I'll even put in some more numbers here, let's say that this is Q. For parts C and D, again, this is for you to try, I'd like you to figure out, on part D, I'd like you to figure out the length. So remember, you should be thinking about circumference here. The length of QN, remember QN is an arc, so I'll use the arc symbol. I want you to find the length there, so you use circumference for part D. And for part C, I want you to figure out the area of the sector QON. So that would be like this portion right here. So again, you're going to use your part A and part B to help you on part C and part D, using area for the portion where I asked for area, and using circumference for the portion where I asked for the length of the arc QN. And so the only important detail here is I'm going to tell you this arc is 36 degrees because this angle is 36 degrees. So now you have to figure out what fraction of the area and circumference you're going to use. All right, good luck.